Hello everyone, it's October the 1st, so we're entering a new month. So there's some lingering issue we have to resolve. So last night I was fighting really hard to try to understand the other solution to the problem. And I was sleepy and just, I don't even know what I was thinking. So I gave another thought today, and it was actually quite a smart idea. So the idea behind is um, we have to start from the very beginning. Like if we know that the final state, when the final state is every values, every number is used to make the subset, right? In the final state. Now, the one step before we reach the final state, right? So we have to add one last number in order to reach the final state. So in that case, what will be the state? What will be the situation that we can successfully create the subsets? Well, the situation that we can create a subset is before we add the last number, the remaining numbers create a state such that they have formed k minus 1 targets plus something remaining. And that something remaining plus the number I'm going to put in will create the last subset, right? So that is how we can achieve the last step. So why it's easy with there since the number there are only 16 numbers of them, right? So we can easily just go one by one, number by number, position by position, 16 positions. At each position, we take the number out, and we ask the question: will the remainder numbers form a state that can create a k minus 1 targets plus the remaining that can form the target with the number that's been taken out? So we ask the question for every single position, right? And then here is the recursion that happens. So for the remaining states, we do exact same thing. For each position, we take one value out and ask will the remaining provide the valid state for us to keep moving forward. So we keep doing this. Basically, what we're doing is given any state, right? Any state that has some numbers taken and some numbers not taken, then we take out the number that has been taken, and then we ask whether the remaining values can form a state such that they will fulfill some number of targets with something left, right? And then we say the next state will be valid if the number taken out, put it back in, will have the remaining values smaller or equal to the target, right? So that's good. That's all good. So I was stuck in the process that we return early, right? So whenever we find one, we just return. I was like, how could this be possible? Like, why don't we check all the other possibilities? Now it turns out you don't have to check all the other possibilities because the value, the DP state, right? The return value is static. The return value is the sum of all the numbers that's currently available in the state modular target. So the value is a static. We already know. All right, we already know. Now the thing we do not know is whether this is possible. Right? Whether this is possible, meaning whether the current state we can find some way to fit certain numbers of target and with something left. This is what we don't know. That's why we have to check every single position and then to see if it is possible for the current state to be labeled as this, right? If it's not possible, it's going to be -1. If it is possible, then the value is only 1. There's only one value, one possible value. Therefore, as we go through every single position, once we find that it is possible to create the current state and like fulfill certain numbers of targets with something left, if that is possible, then we can return immediately. We don't have to keep going. So by doing this, I have a lot of comments here, so to make it look long, but actually it's a very simple algorithm, like very simple, like 10 lines, and then we're done. But performance-wise, this one actually cost me, I just ran it earlier today, it cost me like 1,000 something milliseconds. So it's definitely slow, but we don't know. LeetCode has weird behaviors from time to time. I don't think this one will be any much slower than this because it feels the same to me. But all I want to say is this is a good way of thinking. I mean, we kind of already developed this understanding. When we see an array of values, right? Array of numbers, of letters, if the array size is fixed and it's small, talking about like 30, 40, like it's small, then bit mask. And bit mask is definitely the way to go. All right, so that's that. Next, we have news. LeetCode has changed their user interface for the daily challenge. So the daily challenge is still there. You can see we have the calendar. It's still there, but we no longer have the web page with the red. And I like the red. That's how I handle all of my my what's that called? What's that called? The thing that you can click, right? I don't know, on YouTube. I always choose that image with a red, but now we don't have that anymore because they basically just take that off and decided that all daily challenge would just be like a regular problem. You can see we have there's a daily challenge. It's always on the top. We can access it from here. We can access it from here. So everything is the same. And when you click into it, it goes directly into the regular problem page. So you don't have that special page. Thumbnail, that's the one we're looking for, thumbnail. So I can now do the same thumbnail as before. Anyway, so this is today's problem. And we already know it's medium. We know it's valid. So it kind of hides a little bit of the secrecy, as I would say it. But it's all fine. And this is a very, very classic, right? Classic DP problem, longest common subsequence. And anybody who has taken algorithm class shall be able to write this with their eyes closed. Now let's just go and check to see if this is exactly the same LCS problem that we know. So it's given two strings, return the length of the longest common subsequence. If there's no such a thing, return 0. Subsequence of a string is any string generator. Well, you take something away, and then a common subsequence of two strings subsequence that is common to both strings. So this will be ACE, right? And the value is 3. I think I can solve it just directly. Oh, it's October, so we have to make directory. And then when we copy, we have to copy 1, right? That's 0. No such file. Oh. That type of wrong. 20, that's not 20, that's 20,000. 20, that's not 2021, it's 2020. 2201. Alright, so there you go. Now we're good. I'm going to change this as well. Alright, time flies, right? Time really flies. It's already October. Alright, call this up. Alright, LCS. I think there are a couple of ways to do LCS. The ones that I prefer is bottom up. And let me see, maybe we can do it. I think there's a cheap way of doing this. Yeah, I think there is a cheap way. It's O1 space complex. We don't have to build a n by n matrix. We just need to build one row, right? So DP, so mn equals len text 1, len text 2, right? And then let's say DP is going to be fit which one? Let's say 0 times n, right? shouldn't be n plus 1. Yeah, it should be n plus 1 to make it easier. All right? So now what? So what we're going to do is to compare every single one. Right? So it would be for I in range m, right? For j in range n. Now we're going to compare text 1i and text 1j, right? So we say if text 1i is equal to, so yeah, I think this has to be, let's say, n times 1, right? And then we're going to say if text 1, for each one we have to new, I'm going to give a temp, right? Temp times n plus 1. Right? So each one, we'll say text 1, I, if it's equal to text 2, j, right? If they're equal, then we're filling the temp, right? We're filling the temp. There's a temp, and temp is going to be j, shall equal to dp, right? dp j minus 1 plus 1. If they're equal, they will both go 1 back. And of course, we have to go for 1 to n plus 1. Right? So 1 to n plus 1. Every time we have just go minus 1 and minus 1. Right? And then we can do j minus 1 plus 1. Right? Else, if they're not equal, then if the two not equal, then we do the diagonal thing. Right? With the diagonal thing, we say it's either going to be this, right, the maximum of this, or the maximum of this. So we say temp j will be the maximum of dp dpj, which is just above, and a temp j minus 1. Right? So dpj is just above and temp j minus 1. Right? And once we're done, we say dp equals temp. Then we move on. Now we return. We'll do a return. We'll return at the end. dp equals to temp. That's the new one. Coming back, having no more. So it should be dp minus 1. That should be the last value. All right. Okay, so we'll run a couple of test cases. The first one I have, have a A, B, C, D, E, A, B, C, D, E, A, C, E, that should be 3. Next one is A, B, C, A, B, C, that should be 3. Next one is A, B, C, D, F, that's 0. Okay, and then we have text 1, text 2, and longest common subsequence. I think I've used this in other problems before. Yep. This is a very classic. It's a classic DP problem. I'm surprised I haven't done this before. Oh, they changed this as well. Complete streak, 1 day. Consistency is key. See you tomorrow. They did change stuff. Now we have a little little congratulations after you're done. That's cool. That's cool. Oh, yeah, it's just gone. It would be it's a pop-up window saying congratulations, something like that. All right, so this is one of the most classical DP problems. It's good to practice it from time to time. It's good to practice it from time to time. trick is compare any pair of letters ij in text 1 and text 2. All right, if text 1 I is equal to text 2 j, then the longest then the length of LCS ending at I and j must be 1 plus the length of LCS ending at I minus 1 and j minus 1. If, let's say, these two are not the same, right? That's the other situation. If this is not the same, then the length of LCS ending at I and j must be the longer between the length of LCS ending at I minus 1 j and j, or I and j minus 1. We just continue this, or continue until exhausting both strings. Now this, the DP can be built as a 2D array, but the space complexity can be reduced by using only a 1D array. Runtime is OMN, right? Where M is the length of text 1 and the length of text 2. We got a pretty good result. That's actually going to take a look. 332. I'm surprised I haven't done this before. Like, not on here. I've done it in my class and all that, but not really for LeetCode. Yeah, with tons and tons of people doing this problem. It's classic. It's a classic problem. So what do people say? DP. Yep. Why do you minus 1? Oh, we add this. It's all right. He likes to use this ij in product. It's the same thing, right? Ij in product is the same thing. All right, that will be it for today. We got an easy one. I mean, we know how to solve this. We've solved this many times, so it's an easy problem for us. I'll see you guys tomorrow for the hard one. Adios.